Hello guys, I hope that you're all well. Just one more video. We're going to review a bit of what we did with distance time graphs that you seem to do really well on, and I was really impressed with a lot of the efforts that people have made. And then we're going to look at distance time graph with curves, which we haven't touched on. Okay, the first thing I'm going to go over is just go over some terminology. Here is a circle which obviously has a curved edge. In the event that I drew a line which touched my circumference, essentially a point has been drawn and I've extended the line either side. This is called a tangent. Very important word in maths, tangent. Yeah. I could draw another tangent. It would look like this. Another tangent could look like this. I could be doing an infinite number of tangents if I wanted to. This would not be a tangent. Yeah. This is not a tangent because it cuts through the curve. It must just meet the curve at one point and then be extended either way. That's just a recap because we're going to be using tangents later. Right, here we have a distance travelled in meters, and that should say time in seconds. So let's just look at some scenarios. If I said that there were two people, let's say they both started from home, so the distance travelled, and then this person here, let's just call that person A. And let's have a look at another journey. So let's look at this one here. Let's call this person B. Now, if I just asked you straight away, who went faster? Well, hopefully it should be pretty clear who went faster. Person A went faster. Now, if you say because the line is longer, that's rubbish. We should be thinking about using our proper mathematical language because the gradient is steeper. The gradient of a distance time graph is the speed. So let's just look at this line. So if I went all the way up this line, I know that I've gone up 120. And I've gone across 4. Yeah, so my gradient across 4. So I know that my gradient of A is 120. So my distance up of that line is 120 divided by 4. I therefore know that my speed is 30 meters, because this is in meters, per second. Pretty quick if you think about it. It's saying for every second that passes, 30 meters has been travelled. Okay, let's just double check. So if I looked at the gradient of B, I know it goes 40 up. Gradient is distance up over distance across. And 4 across. So my gradient of B would just be 40 divided by 4. This one's going at 10 meters per second. So if I wanted to compare them. Right, let's just recap a potential scenario. So let's say that someone sets off on a journey. This is all going to be moving very quickly because it's set the time is in seconds, but just for the sake of this example, we'll have to do. I'm going to say that this person has moved 40 meters in 2 seconds. They take a rest, then they return home. Right. Now, hopefully we can see what's the furthest distance, might be one of the questions. The furthest distance away from home, we can just see that the furthest distance is 40 meters. For how long did this person rest for? Well, they went between 2 and 5, so they rested for 3 seconds. Did this person move more quickly, with a greater speed? I should use less vague language. Did this person move with a greater speed for the journey going out or the journey returning home? Well, how would I know that? I'd have to take the gradient. So on the way out, this person moved 40 meters. It took them 2 seconds. So on the way out, they were traveling at 20 meters per second. And on the way back, looking at the gradient of this line, know that they came from 40 meters, they traveled 40 meters, and they did that in 1 second. Therefore, we'll have 40 divided by 1 equals 40 meters per second. Whoa, in fact, they've moved a lot more quickly. Their speed is much greater on the way home. I hope that the more observant of you will recognize that the gradient of this one is positive and the gradient of this one is negative. However, because we are dealing with speed, speed doesn't care what direction of travel you are moving in. Speed is just speed, yeah? So 40 meters to home or away from home, it doesn't matter. So I'm just going to write 40 seconds. The actual gradient is negative 40, but the speed is 40. In the event it wanted a direction, the direction was important, I'd stop referring to this as speed and I would call it velocity. However, we're not going to be doing that. Right. We will move on to velocity time graphs soon. It's a difficult topic, guys, so it's important that we sort of understand that language. Right. Do we have that one there? Right, so at these points, I knew that they were moving with a constant speed. Why? Because the lines are straight. For every 20 meters that passed, 20 meters that were covered, it took 1 second. For every 20 meters that passed, it took 1 second. Yeah? Stays the same regardless of where it is on there. What? That's a rubbish line, even by my poor standards. What if it wasn't like that? What if it was this, a curve? Well, what would a curve tell us? A curve would tell us that it is not moving with a constant speed. If something is not moving with a constant speed, its speed must be changing. If it's a curve and the speed is changing, it must be acceleration. Acceleration is the change in speed. Well, how would I work out, say, let's think about a specific question. So I said work out the speed, where would be a good point, after 4 seconds. Well, what I do not want you to see you doing is just going up from 4 seconds, picking a point and then going, oh, it's 40 divided by 4. We're not doing that, yeah? That is not the speed at that point. In order to work out the speed of a distance time graph, time. In order to work out the speed of a distance time graph, we must draw a tangent. Speed of a distance time graph, we must draw a tangent. Yeah? So at this point, you can draw that point if you want. Then what I would do is extend out using a ruler. Draw a tangent from that point. Tangent comes down here. And can I get it? And comes down here. A tangent is not an exact science. Yeah? It is an estimate. Because different people are going to look at it slightly differently and draw tangents with slightly different gradients. Now after I've drawn my tangent, I'm now going to work out the gradient of the tangent. So what do I know? Let's just read across from here. I know that it has gone 104, I believe. So it's travelled 104 up. So the gradient up, it's gone 104. And then the distance across of my tangent, I suggest you draw your tangent nice and big, would be like 2.2 if I'm being exact, which I should try and be as exact as possible. 2.2. So whatever that is, sorry guys, I don't have a calculator, frustratingly. I do not have a calculator to hand. The only place that is on my phone, and I'm obviously videoing this on my phone. So the speed would be whatever 104 divided by 2.2 is. Do not leave it like this. Work out what it is in your calculator and then give it as meters per second. Let's just play out one more scenario. So if I was instead asked for what the... I don't want that. Stop doing that. If I wanted, say, the speed at a different time, let's say I wanted the speed at, let's say at, say 6 seconds. I'd go to 6 seconds, so 6 seconds is here. I'd draw a point, then I'd draw a line, I would extend it out. And extend it out. And then I would work out the tangent of this, the gradient of that tangent. Hopefully we can see, because if I was to draw tangents at this point, the gradient would be small, and then it's getting steeper and steeper and steeper. So it's actually getting faster and faster, it's accelerating. Yeah. So to be clear, if you're asked to work out the speed from a distance time graph and it is curved, find the point, draw a tangent, work out the gradient of that tangent. Have a go. It's just the final question with these questions that I've set you, but it's very useful for us to know this and use that terminology. I hope you're all well, keeping well. Speak to you soon. Bye.